Okay, I will start the conference. The official language of our conference is English. So, good morning, dear colleagues. Good morning, dear participants and guests of our conference. And as you all guys know, due to the pandemic coronavirus situation in the world, we will have virtual conference this year. This is the second IEEE International Conference on advanced trends in information theory. My name is Victoria Ivannikova. I am Secretary of Information Theory Society of IEEE Ukraine section, as Alexander Konstantinovich told at the beginning. And I will moderate today's conference. Traditionally, the IEEE conference will be opened by the chair of IEEE Ukraine section. It's well-known scientists, my colleagues from the National Aviation University, head of the department, Professor Felix Yanovsky, and he is also the IEEE Life Fellow. So, Professor Felix, the floor is yours, and we are very pleased to listen your presentation.
Thank you very much, Victoria, for the introduction. Do you hear me?
Yes, we hear you well.
Okay, thank you. I will try to include my presentation now. Just a moment. Do you see my screen?
Yes, we see it well.
Okay, thank you very much. Good morning, dear colleagues, ladies and gentlemen, the participants of the conference on advanced trends in information theory. My name is Felix Yanovsky. I am a professor of electronics, robotics, monitoring and IoT technologies at the National Aviation University. And a couple of words about my IEEE activity. It was started in 1994 when I joined IEEE during the Antenna Conference in Seattle, United States. Since 1996, I became senior member of IEEE, and since 2008, I was elected as the IEEE Fellow. As the IEEE volunteer, many years ago, I was the founder of the IEEE Signal Processing and Aerospace and Electronic System Society chapter in Ukraine. And in 2016, I was elected for the first time, and currently I am again a chairperson of the IEEE section in Ukraine, the main IEEE entity in our country. And now in this, my capacity of the IEEE Ukraine section chairperson, I would like to welcome all of you at this opening ceremony of the Second International Conference on Advanced Trends in Information Theory. A couple of words about the Institute of Electrical and Electronics Engineers. It is the world's largest professional association dedicated to advancing technological innovation and excellence for the benefit of humanity. IEEE now has more than 420,000 members, almost 500,000 members in more than 160 countries. And you perhaps know, but maybe not everybody, because not all participants of the conference are IEEE members, unfortunately. I would like to say a couple of words about IEEE structure. All the world is divided by on 10 zones. the first 6 zones are located in the United States of America. 6, from 1st to 6th. 7th zone is Canada. 8th zone is all Europe, Africa, Middle East, and all the Russia. And 9th zone is South America and Central America, including Mexico. And finally, 10th zone is China, India, Australia, so Southeast Asia. This division, a little bit strange because 6 zones are in USA. It is related with actually that fact that IEEE was created in USA, and USA has much more members than other countries. One city, Boston, has much more members than all the Ukraine. And actually section, it is, of course, geographical division, but not exactly the number of sections is not equal to the number of countries. In US, we have a lot of sections. In Ukraine, we have 1 section, even more. Ukraine section include also Georgia, because Georgia has a limited number of members and they are included in Ukraine section. Russia has 3 sections, for example, in Moscow, in St. Petersburg, and in Novosibirsk. That was geographical division. And a simplified IEEE structure, which is indicated here, in addition to geographical division, where IEEE is divided by region are divided by sections, and student branches, and so on. There is also professional division, division on application areas. And from this point of view, IEEE has societies. There are 39 societies, and societies create chapters together with sections in different sections in different countries, and there are around 2,200 chapters in the world. Here you see the list of societies. There are 39 societies. Among them, there are many societies which are of great interest of us and of your conference also. And I also created a slide with a limited number of societies which are the most popular in Ukraine, where we have chapters related with this society, and the youngest chapter is your chapter, Information Theory Society chapter. IEEE is actually a very important professional organization which conducts a lot of international, the most interesting, popular, and great conferences in the world, and also it is a greatest publisher of the most, let's say, respected professional journals. Hundreds of journals are actually created by the IEEE. Each society has their own journal, even not only one. And publication in such journal, it is the guarantee of success. That means that your paper will be cited, it will be known, and it is very important to make publication in IEEE journals. Unfortunately, it is not so easy. And it is absolutely not true that it is necessary to pay money for that. The only important, let's say, condition is to have a very nice, very strong, very interesting and original paper. If your paper is, after the reviewing, accepted, it will be published, even if you are not able to pay money. So don't believe to that person who say that it is necessary to pay obligatory big money. They can ask to donate. That's true, and you should pay for additional papers. But if your additional pages, sorry, if your paper has a limited number of papers, for each journal is different. For example, 6 pages. It can be published free of charge. Another important activity of IEEE is IEEE standards. I believe that everybody knows that IEEE standards are used everywhere in electrotechnics, electronics, information technology, and so on. You can see here some examples of IEEE standards, and you can see that no LAN, MAN, WAN, Ethernet, Wi-Fi, Bluetooth, WiMAX, ZigBee, different things, cryptography would be not possible without IEEE standards, because internet actually is not possible without IEEE standards. Otherwise, we were not be able to have let's say, compatible devices everywhere. So the, let's say, activity of IEEE is very, very important for us. Moreover, in the framework of IEEE, there is so-called Future Direction Committee, Future Directions Committee, which actually is a kind of IEEE's innovation engine. They actually can determine which direction of development are the most important for this period of time. And for example, recently, IEEE Future Directions Committee, let's say, determined these 8 directions of development where our innovation should be, let's say, directed. It's a big data, cybersecurity, green information communication technology, Internet of Things, rebooting computing, smart cities, smart materials, software-defined networks. And of course, all of them are related between themselves. It is everything very important for all of us and for your conference as well. I would like to say a couple of words also about the development of IEEE in Ukraine. The first steps of IEEE in Ukraine were done in 1991. Actually, in that time, Ukraine scientific community in Canada sponsored IEEE membership in our country, and they sponsored the first 50 members. They paid for them in 1991, and the IEEE Ukraine section was established in November 1991, in 2 months after the declaration of Ukraine independence. It is also a very symbolic fact. And the first IEEE members in Ukraine were scientists and teachers from Kyiv Polytechnic Institute. That is not because they are very wise, clever, and so on. It was just a situation when it was inspired from Canada, and then Rector Petro Palanchuk was the Minister of Education, and he was the first section, the first chair of Ukraine section at that time. But of course, you know, when some organization, it is a public organization, is created from the top, it is not very active. Actually, the real activity of IEEE started in when chapters were created. The first chapter, first 2 chapters were created in 1995. And it was done with assistance of IEEE Poland section, and personally Professor Joseph Modelski, who is our big friend of Ukraine. And the first chapter organizers were in Lviv, Professor Nikolai Voitovich, and in Kharkiv, Professor Alexander Nosich. Later, many other chapters were created also. current IEEE Ukraine section committee, you can see our members of this committee, and also all chairs of all chapters are also invited as members of committee. We have now very democratic, let's say, structure and work, and we are working together with our local chapters and society chapters and affinity groups and so on. Here you see a picture of one of the section executive meeting. Actually, we have said that Ukraine section now is representing the Ukraine in Ukraine and Republic of Georgia, as I have mentioned already, and around 250 members we have, 14 technical chapters, and 2 affinity groups, particularly young professionals and women in engineering. And IEEE Ukraine unities organize and support local events, a lot of conferences. We have liaison with professional societies, with local professionals, and much, much more. Here you see in this slide the examples of the IEEE conferences which we organize regularly. It's just examples, and many others among the conference which are organized by IEEE members of Ukraine under the supervision of IEEE Ukraine section, and your conference is among them. In 2017, we organized the first Ukraine IEEE conference on electrical and computer engineering, UPERCON, which was established and organized as the flagship IEEE conference in Ukraine. And the next UPERCON was held in 2019 in Lviv. It is very also important to say that in 2017, the Ukraine IEEE section was able to, let's say, we submitted and we published a lot of historical papers about development of microwaves in Ukraine, about radar activity even from Soviet times, but it was Ukraine. Ukraine was the UN member and actually formally independent country in accordance with Constitution of the USSR. That is why we were able to achieve the highest recognition of IEEE. It is a kind of it is named milestone. In 1938, Ukrainian Physical and Technical Institute in Kharkiv created this radar, Zenit, which was the first radar with in this frequency band with parabolic antenna, which was able for the first time to measure all 3 coordinates of the air target. So it was possible to measure force range and also azimuth and elevation angle, and it was recognized officially by IEEE, and we got the special IEEE milestone. It is the first such kind of recognition in our country, but I believe it is not the last one. Here you see a picture when the director of IEEE Region 8, Kostas Stasopoulos, actually this is the placket, it's a big bronze placket, which is handed to IEEE Ukraine section, actually not to section, to Ukraine. And now it is this, you can see this placket, it is very heavy. And now it is given, it is installed on the wall near the Dean office of radio physics faculty in Karazin State University in Kharkiv. Not because in that university it was done, but because It was done in Ukrainian Physics Technical Institute, but it does not exist anymore. It was actually after the war, it was not renovated. But the majority of persons who participated in this work, they were in the past the students. They graduated from this university, and it is very important thing. And now I would like to say also about other conferences, and among them our conference, second international conference on advanced trends in information theory, ATIT 2020. I would like to say that organization and conducting IEEE conferences, it is a very important and useful for our scientific community, for our country, and for each of participants personally. A lot of our collaborators have IEEE Explore and Scopus and Web of Science publications thanks to our IEEE conferences, like this conference on advanced trends in information theory. In this connection, I would like to underline that you should remember that quality of your papers and presentations is the only guarantee that this young conference, it is the youngest conference, IEEE conference in Ukraine, will be successful and continue its successful life in the future. The requirements to the IEEE conferences become stricter every year. The reviewing and selection of papers for the inclusion into the program become more sophisticated. That is why I have a good reason to congratulate all of you, all participants, that your papers are now in the program. On behalf of the IEEE Ukraine section, I would like to thank Professor Alexander Yudin, the conference chair, and Dr. Victoria Ivannikova, the chapter secretary, for their good job to organize this conference in spite of this awful COVID-19 pandemic. On behalf of IEEE, I congratulate all of you, the participants of the conference, with this, I hope, successful start of the conference. I wish you sincerely to make a very nice online presentation, to get new knowledge and impressions, to have interesting discussions during this second IEEE conference on advanced trends in information theory. I would like to wish you a nice ATIT 2020. Good luck, and good health. It is now important to everybody. Thank you.
Thank you very much, Professor Felix, for your very interesting report. And now I would like to give a word to the chair of our section, Professor Alexander Yudin.
Good morning, IEEE members, speakers, friends. Welcome to the second IEEE International Conference Advanced Trends in Information Theory 2020. Dear participants of the IEEE International Conference, I am very glad to see you all at our conference and would like to describe the organization concept of IEEE International Conference. As you know, this is the second conference which is held under the 2020 IEEE International Conference of IEEE Ukraine Section Information Theory Society Chapter. Conference focus is on the processing, transmission, storage, and use of the information, as well as the foundation of communication process and information technology. It specifically encompasses theoretical and applied aspect of coding, communication and communication networks, information technologies and artificial intelligence, detection and transmission, Shannon theory, and statistic process. Information theory included source and channel coding, communication theory and information systems, cryptography and information security, network statistics, communication theory, and signal processes. The conference will offer a great opportunity to exchange new results and challenge about modern information and communication technologies with the objective of increasing productivity within various industrial sectors and service providers. And this is a significant aim for us and the University of the Ukraine. Congratulations. We start. Conference track, information and encoding theory. Second track, communication theory, technologies of information security. And track 4, information technology and artificial intelligence. And I'm start for the conference consultation. And now first report and Secretary of the conference, Victoria, please.
Okay, thank you, Alexander Konstantinovich. So the next report is report of academic Vyacheslav Petrov from the Institute for Information Recording of the National Academy of Science of Ukraine. And I'd like to remind to our participants that we have time limit for the presentation, so it's 15 minutes. Please be so kind to finish your presentation according to the program times. Okay, so Professor Petrov, you are very welcome.
I was chosen as a speaker, okay?
Okay, so please.
Well, do you see my screen?
No, not yet.
Sorry, I first time here. Should I? Yeah. Now, do you see?
Now, yes, we see now your screen. Okay.
Thank you. First time. Okay. I'm senior researcher of the Institute for Information Recording. I was chosen as a speaker. So the presentation is designed to present some important points of creating optical media for long-term data storage. It includes results for theoretical and practical research conducted at Institute for Information Recording of National Academy of Sciences of Ukraine. As you well know, recently a significant number of data centers have appeared in Ukraine as well as throughout the world. One of the urgent problems in this area is creation of technical means for long-term storage of information. Data center storage configuration includes data in motion, data in use, and data at rest, often called cold data. Cold data must be stored reliably for a long period of time. Thereby, long-term data storage development is a hot area of modern IT and engineering. Nowadays, there are large numbers of public funds and projects for long-term data storage. It should be mentioned that in most cases, optical encoding on monocrystalline substrate is considered, because it's quite reliable, it's crystal. Information recording trends graph demonstrates that the main disadvantage of optical media is low recording density. The solution of the problems includes both increasing the recording density at surface of the media disk, for example, and application of volumetric recording methods. So our investigation included both methods for getting reliable long-term media and media with big enough information capacity. Most technologically simple method of volumetric recording is to create a multi-layer photoluminescent disk. At the Institute for Information Recording, there are proposed methods of the crosstalk noise reduction, which is typical for this type of media. While there are many layers, so we get some crosstalk noise. There are length information encoding instead length of bits information recording, which is typical for optical disks, and creation peripheral zone. As we calculated, we can with this means we can achieve signals noise ratio minimal value up to 10 to 1, which is good enough. Optimal photoluminescent disk structure parameters calculation, it was shown that for this type of information media, the technological requirements for the formation of information layer microstructure are even harsher than for modern formats of optical disks like Blu-ray. The purpose of further research included analysis of state-of-the-art methods of the technological for creating media for long-term data storage, substantiation of methods of representation, and coding of information of long-term data storage media, and examination of the effectiveness of proposed methods. So the main part of our investigation, we made some practical research and was able to use equipment which usually used to produce stamps for optical disks. But now we made disks not from polycarbonate, but from sapphire monocrystalline substrate. So information layer microrelief structure were formed at sapphire substrate. They were obtained macro-etched images of strictly controlled depths, which is a quarter of wavelengths. So for sapphire substrates, we required 440 nanometers wavelengths for data reading. The pinhole depth was 64 nanometers. It should be noted that micro-etched data presentation on the surface for the long-term storage device was chosen because it enables data readout using different physical methods. If in future we don't have specialized devices for readout process from this kind of optical disks, we can use other methods, for example, conventional optical microscope with good enough resolution. Thereby, it was proposed the new complex methods for producing long-term data storage devices based on the use of optical media with sapphire substrate and optical readout, presenting data as micro-etched structures. Data can be retrieved from optical storage devices containing records as submicronic etched structures with a scanning laser beam using conventional compact disk drives or dedicated devices or optical microscope. As the data coding method, we propose to use non-binary codes working with digital data with group errors as components of cascade codes to ensure error control, which are used to produce compact disks as well as DVD, Blu-ray, and so on, and other formats which currently are not used. So thank you for your attention.
Thank you very much, Evgen, for your very interesting presentation. And if someone have questions, please, you are welcome to ask. So if there is no questions, we will go to the next speaker. And I just like to announce and just like to thanks for the participants of the conference, because we are rather in a big amount today. So there are 73 participants in today's our conference. So thank you for your participation. And our next speaker is Professor Yuri Kravchenko from Taras Shevchenko National University of Kyiv. And the topic of his report is synthesis of the structure of multi-level hierarchical system of increased variability based on a subjective probability model. So, Professor Yuri Kravchenko, please, you are welcome.
Thank you. Good morning, dear friends. I
Good
am very
morning.
glad to see and listen to you. I wish you achievements in science. So, the first speaker in this topic, Professor Victor Bondarenko. Please, Professor Victor.
Thank you very much. I will prepare now my presentation. I'm Victor Bondarenko, professor of Computer Science Department of National University of Life and Environmental Sciences of Ukraine. Theme of my report is synthesis of multi-level hierarchical system structure of increased survivability based on a subjective probability model. Is devoted to synthesis of complex multi-level hierarchical systems of high survivability. Usually systems operate in a complex environment that has a social, physical, sometimes economic, political nature. Therefore, this environment influence on such systems. Often, such influence is destructive. Therefore, the problem of developing survivable telecommunication, computer networks, and other complex multi-level hierarchical systems that are able to counteract such influences is very important. Destructive influences on a system are usually random, but to estimate random on such type, the using of classical probability theory has serious difficulties because such actions don't have mass character, which is necessary to estimate the frequency of such events. Therefore, this report proposes an approach to assess the probability of random influences of such type on the base of experts group knowledge. Such estimation is called subjective probability. We can construct such systems on the base of any model, and main element of this model, this variable xij, this variable equal to 1 if device number G is connected to a device number I of system, and it equal to 0 if device number J is not connected to device number I. On the basis of these variables, we can construct survivability function as it has such it is we can see it on as Formula 2, where Cij is subjective probability of connection, survivability of the device J to device I. But model, besides this M function, model has several restrictions. First restrictions we can see as Formula 3. The total number of devices connections must be one less than number of all devices. This is first restriction. Second restriction, we can see on this as this expression that it means that to one unit cannot be connect elements more than p elements. And next restriction of model, this each element of network structure must be connected to more than one higher level element. This next restriction number 5. And next restriction, the system cannot has contours because this is hierarchical systems, and it should not have contours. And this expression 6 can, if this expression can be done in such system, we will not have contours. And we should use next restriction that we cannot have isolate elements in our systems. This restriction can be impossible to have such elements. According to this restriction, system cannot have such isolate elements. And this system, this model is model of linear as linear programming system. But the important coefficient coefficient Cij. This coefficient is subjective probability of the connection, and it shows survivability of the device J, connection of device J to device I. And in what manner we can receive these coefficients? Suppose we have n states of this any connection. This states D first, D second, Dn. This, for example, what is a connection, state connection? Connection is fully operational or don't operational or another possible states of this connection. Besides states, we have any features or influences of environment. Suppose there is a set of M features or influences, K first, K second, and so on, that accompany the states. For example, the cable breaks, breakage, or switch feature. Experts assessment, but this assessment is formed into a matrix of states, expert assessment. But these elements, we can use probability, so standard probability theory, because these influences don't have mass character, and it's impossible to find frequency of this these influences, destructive influences, and in such a case, it's impossible to receive probability, standard probability of any destruction events. In this work, we suggest to use subjective probability, which is based on experts' opinions. Expert assessment is formed into a matrix of state. For example, we have such a table where column and rows is marked by states, D first, D second, and so on. And the experts in this cells of this matrix put such value which he can which means how many times more often states, for example, E that marks the row of this matrix occur more often than the state dj that marks the column of this matrix. For example, if state d first 3 times more often than state d2, he put on this in these cells value 3, for example, 3, and so on. And similar to the state matrix, experts construct a feature or influences matrix. For each state, such matrix is constructed for each state D of the system, and this matrix is max row and column of this matrix is marked but these features or influences, and such matrix is built for every state di, for example. Further, the vector we can on the base of this matrix we can build vector vector d. This is average geometrical of row states, for example, and we from such element of vectors estimate vector, we can calculate subjective probability of d of state, for example, di with such formula, and conditional subjective probability p k, for example, I if we have state dj, calculate with the same formula, but we used table, such table for every state, table of influences. We have, in such case, we have probability, for example, p probability of states, and conditional subjective probability for k any influences k in d any state dj, and according to bias theorem,
И результаты. Отлично. И, короче,
according to bias theorem, we can find the subjective probability of d in any state di if we have influences set influences b. Set influences b. According to the theorem of additional probability, we can calculate this coefficient Cij in m function, this is in such manner.
Dear Professor, sorry for interruption. I just like to kindly remind you that we have rules of our conference. The duration of your presentation shouldn't exceed 15 minutes. So please follow our rules.
Excuse me. And on the base this model, it was constructed system on which allow us to construct any hierarchical systems with high survivability. This is all. Thank you for attention, but
Thank you very much for your reports. And if there is any questions, please, you are welcome to ask and we will discuss. No questions? Okay, so if there is no questions, we will go to our next speaker. Next speaker is Professor Vladimir Barannik from Kharkiv National University of Radio Electronics and Associate Professor Sergei Shulgin from Kharkov National University of Radio Electronics. So, dear colleagues, please, you are welcome. The floor is yours.
Good day, dear colleagues. Good day, dear colleagues.
Good morning.
Please receive my warmest regards due to our conference event. Our presentation prepared together with Associate Professor Sergei Shulgin. Let me give word to him to make presentation.
Okay, thank you. And I just once more want to remind you, please follow the rules of the conference and our time limits. 15 minutes for each presentation. Thanks.
Good day, dear colleagues. Can you hear me well?
Yes, we hear you well.
Thank you. First of all, my best regards due to this event. And let me start. Thank you, Professor Barannik, for introducing me. So I'm just preparing our presentation. Can you hear? Can you see slides?
Yes, we see them.
Okay. So, methodological basis of decryption coding of segments of the aerial photography on the special equipment of unmanned complex. The consequence of the use of existing onboard image processing technology leads to a significant reduction in the resolution of aerial photography. In the future, this affects the efficiency of the decoder. A conceptual aspect of solving the problem of providing aerial photographs using onboard monitoring systems is a methodology based on the implementation of two-stage technology of intellectual processing of aerial photography. For the purpose of this methodology, realizing decryption coding is being proposed. This technology aims to obtain key decryption features for further processing of the entire aerial photograph in order to preserve semantically important decryption information, to improve the quality of remote video service systems, and to provide actuality for the decryptor online. The technology of decryption coding is based on the idea of intellectual processing of aerial photographs with the selection of key features of decryption. The functional diagram of the decryption coding technology, picture 1, includes two levels of on-board processing of the aerial photograph, semantic and syntactic. The operating of the semantic level is to determine the deciphering redundancy and the degree of deciphering informativeness. So the key information is to be deciphered as is revealed. The operating of the syntactic level is to eliminate the deciphering redundancy of the aerial photography by identifying patterns in the correlation of its elements and their structural sequence with its subsequent coding. To implement the operating of the semantic level of decryption coding technology, a conceptual methodology for automatic evaluation of segments of aerial photographs according to a two-stage concept for decoding informativeness has been developed. To highlight the key deciphering features of the image, as well as the classification of segments of the aerial photograph by degree of importance, all segments of the image go through a two-stage system I'm sorry, of identification of segments as they obtain decipher informativeness. The first stage checks the segments for the presence or absence of decryption information. In the second stage, an assessment is made as to how informative the segment is from the position of the decoder. The development of the first stage is the process of segment identification involves the stage of localization of contours in the dynamic range in the gradient space and their detection by transforming the space into a binary representation. It is proposed to use the Pruitt method. As a result, a mask is formed in the SO segment. The next stage involves the formation of integrated metrics to assess the content of semantic informativeness of the segment on the elements of its key deciphering features. Here, the accounting of gradient transitions is performed as the number of binary differences in two-dimensional binary space. That is, the structural quantitative metric of the segment is determined. For this purpose, it is offered to use structural features of binary masks, existence of contour elements on a positional coordinate of a mask of a SO segment, two-dimensional binary field of transitional form from the background state in the element of key information, the presence of a relationship between the elements of key information. The result of these stages is the calculation of quantitative metrics to assess the level of semantic informativeness of the SO segment of the aerial mask. The final stage of the first stage of the proposed technology is to assess the level of semantic informativeness of aerial segments. It is used the threshold level between the degree of semantic informativeness of the segment and the value of its structural quantitative metrics on the elements of the key deciphering features.
Что ж такое? Ты услышишь еще эту историю, там не совсем то, что было.
The segment class is set, informative or non-informative. It is proposed to estimate the degree of key segment information as a percentage of the maximum possible limit. For a structured mask, such a limit of informativeness will be the fullness of its individual elements. The development of the second stage of segment identification by the degree of their decipher informativeness involves three technological stages. The first stage involves obtaining transformants DCT and the selection of high-frequency components in it. The more frequent, the brighter differences, and the larger the area field with small details and quantity differences, as higher the semantic informativeness. The second stage is proposed to be implemented on the basis of detection of segments with impulse changes in the values of image elements. The use of information in the field of high-frequency component of the spectrum, which is in the last diagonals of the transformants of the segment, is proposed. This allows us to assess the energy significance of the elements, impulse changes in their values, in the most informative segments, from the standpoint of decoding. The final stage is the selection of segments with a high level of deciphering informativeness. Here, there is a rule of decision-making on the energy significance of the segments based on the indicator of the total value of the high-frequency components of the transformant DCT informative segment of the aerial photograph. The rules are based on a system of comparing the value of the integrated indicator of energy saturation with a certain threshold value. The informative segment of the aerial photograph will be considered highly informative if the total value of the high-frequency components of the DCT transformant exceeds the specified threshold level. Otherwise, the informative segment of the aerial photograph will be considered sufficiently informative. This method allows to select in segments elements of key decryption information, classifies segments of aerial photography as uninformative, sufficiently, and highly informative, reduce time on the identification of monitoring object. Increase the efficiency and accuracy of monitoring the Earth's surface. Adjust the operating of the unmanned complex with a monitoring function during a crisis situation. Distinctive Distinctive features of the proposed technology are automatic determination of the amount of deciphering informativeness of the segment by establishing cascading empirical relationships to obtain informativeness, taking into account structural and combinatorial pattern in the field of spectral representation and binary.
Я думаю, просто Олегу надо проверить, как все работает. Проблем.
For the quantitative identification of segments of the aerial photographs by the degree of decoding informativeness in remote video systems. Thank you for your attention, dear colleagues. Probably you have questions.
Thank you very much. And dear participant, local time is the basis problem of all conference, but reglement is basic of all conference. Thank you very much. And now next report, Professor Rolik Alexander, University Sikorsky, Kyiv Polytechnical Institute. Please.
Good morning. We are ready to proceed to our presentation to be given by Valery Kolesnik. Valery, please.
Yes, hi colleagues. Let me share my screen. Okay, do you see my screen?
Yes, we see.
Yes.
Okay. So we want to present you research with the title Marginal Utility Approach for Quality of Service Evaluation in IT Infrastructure. So first I want to start, let me present it without timer. Okay, let me do like this. Let me start from the content of the presentation. I will start from introduction, then we will move to quality of service management model, which we use in all our research, and then we will go to problem statement. After that, I will explain a little bit about what is marginal utility function. Then I will show you analysis of the proposed solution based on the data which is open over the internet from Grid Workload Archive, and then I will show the results of the application of the proposed solution. And at the end, I will conclude the results. So, first of all, the introduction to the topic. As you all can know that the paradigm of service-oriented computing is
Да не, ну это же задача, вот. Она поменяла success на S-ку по чудесным стечениям обстоятельств. Вчера... Ну, почему было XS? Потому что в Confluence есть дока, как получить SSL.
Excuse me. The culture of the conference.
Ладно. С SSL-сертификатом есть дока.
Dear participants, remember that your cameras and microphones...
Просто меня мьютит перманентно. Написано host muted you. Что такое?
Я Хлевотенко.
Кто-то не хочет, чтобы я говорил за сертификаты или что? Что такое? Не знаю. Типа, ладно. Окей. Руки на стол. Прошел по доке, получил файлик, пошел к параллельной команде, чтобы они мне выдали сертификат. Не зажлобтились, сказали, мы не хотим тратить деньги.
Господа, это наш или нет?
Окей.
Я его
Пишу,
читаю.
как мы можем это решить? Тегнули Дэвида, Дэвид сказал, типа, мы хотим все автоматизировать части SSL сертификата.
Минус.
Thank you very much. Excuse me.
Okay. Can I proceed?
Yes, proceed.
Thank you. So, as you probably know, that paradigm of service-oriented computing is quite spread around the world, and due to the usage of this paradigm, such entities has emerged like IT services, and therefore there is a need for managing such entities by the means of, for example, some kind of indicators which can be presented like quality of service measurements. And there are a lot of researches in this area, and a lot of different point of views regarding the different indicators, and also different approaches how to combine those indicators. However, there are at our standpoint that there are two distinct indicators which can be shown in quality of service, which are technical and human indicators or subjective indicators. Once you can measure technical indicators and evaluate them by some formula, for example, then it can be automated. However, when we speak about the subjective evaluation, it can be quite hard because we need to to ask some people to give some evaluation or give them some kind of questionnaires in order to understand how good the quality is for some specific service, because we cannot rely on the technical indicators only. That is why we have proposed to use marginal utility function, but about this a bit later. First of all, our management model, which we use in our researches, it is based on 3 management loops, as you can see from the figure. The first management loop is outer loop. It is responsible for designation and implementation of business processes which are taking place in IT infrastructure. The inner loop, which is responsible for mapping of those business processes to IT services. And the last one, which is service level management, which allows let me say, different software tools and IT department to provision the service on this agreed level or specified level of quality. Of course, with a reasonable usage of resources. And what the problem? As I said previously, we need somehow to combine not only objective indicators, but also subjective indicators. And therefore, we have decided to use marginal utility function, which previously was introduced in behavioral economics area. However, it was also applied in the management area of IT services. And what is actually a marginal utility function? This function was suggested by Bernoulli as logarithmic function according to the behavior of, for example, consumers of some good. And what does it show? As you can see from this figure, when we increment some amount of some good, for some delta. For example, here the delta is just a half or 0.5. And on each step, with further increment in this consumed good, the increment in overall satisfaction becomes smaller and smaller. So at the first step, when user has only just a half of some good provided, for example, he has, let me say, in terms of Bernoulli research, he has, for example, $10. And when he gets increasing $5 from 10 to 15, he will be more satisfied than if he get increase from, for example, $1,000 to $1,005. So the delta in satisfaction will be smaller and smaller, and for example, further increment in the same delta just will not have any result on the satisfaction. And how it can be used in the area of IT infrastructure quality of service management. We have used the over-grid workload traces from Grid Workload Archive, and we have computed the values which refers to as violation time for each task which is performed in the IT infrastructure. And if the violation time, if the performance time of some job is greater than required, time, then we calculate it as a delta value and say that it is violation time. And because of the data was collected during 1 year and more, there are a lot of different kind of data which should be normalized, because there are also a lot of outliers. That is why we have used log normal function here. And according to the marginal utility function, we can see the results here on this figure. Also, we have introduced this parameter of satisfaction as quality of experience, and by points you can see the same points which you saw on previous figure. And regarding this figure, you can see that relative violation time, actually also just need to be explained that relative violation time here is reversed value to violation time. So it's like 1 divided by violation time. And the bigger violation time, the smaller value of experience you can see here. So as the result, we can see that actually, according to the previous figure, there are 2 distinct groups of values which can allow us to suggest that some violations just can be ignored during management and to be skipped, because what can be seen is that just it doesn't need to provide some kind of management function to normalize the value. Otherwise, if we have values which shows relative satisfaction quite low, like 0.6, it requires us to apply some kind of management function which can normalize these values. And actually, that's all. Thank you for your attention. If you have any questions.
Thank you very much, Valery. Please, participants, if there are any questions, you are very welcome. And let's discuss. No questions. So if there is no questions, I just want to make some remarks that the organizing committee of the conference kindly asked the chairperson of the tracks to apply something like sanctions to the violators of the rules of the conference and to remove these violators from the program of the tracks. And please follow the rule of the conference and remember that your cameras and microphones are on. Okay. So if there is no any more questions, and we can come to our next speaker. The next speaker is Fang Li from the National Aerospace University, Hai, and Professor Vladimir Lukin from the same university. The theme of the report is an approach to better protocol graphics, BPG compression, with providing a desired quality. So Professor Vladimir Lukin and Fang Li, you are welcome. The floors are yours. Do we have Professor Vladimir Lukin?
Yes, he is online, but he doesn't respond, unfortunately.
And what about Fang Li?
Can't find him.
So
maybe the next, and meanwhile, I'll try to contact to Professor Lukin.
Okay, so let's go to the next presentation. The next presentation is presentation of Professor Emil Faure from Cherkasy State Technological University, Ukraine, with the presentation 3-pass cryptographic protocol based on permutation. So Professor Emil, you are very welcome.
Thank you very much. Good day, dear colleagues.
Good day.
Let me share my screen. Do you see my presentation?
Yes, we see it well.
Okay, thank you. Dear colleagues, I'm here to present the research named Three-Pass Cryptographic Protocol based on permutation. This work is performed in Cherkasy State Technological University. One moment. Okay. A three-pass cryptographic protocol uses a function for encryption and a function for decryption, E and D. The encryption and decryption functions can be the same or different. An encryption key E is used by the encryption function to convert a plain text message to a ciphertext. For each encryption key E, there is an appropriate decryption key D, which allows to recover the original text using the decryption function. Inequality 2.2 must hold for any message M, any encryption key E with the appropriate decryption key D, and any irrespective encryption key K. The property is possessed by commutative encryption. Suppose Alice wants to send Bob a message. Then the three-pass protocol works and follows. The original plaintext message is entered by Alice with her key, and the ciphertext is sent to Bob. Bob re-encrypts the first message using his key and forwards a double encrypted message back to Alice. Alice performs the decryption procedure on the second message using her key. After Alice's decryption procedure, the message is encrypted only with Bob's private key. Alice forwards the ciphertext to Bob. Bob decrypts the third message with his key and gets the original message. The first and the most famous three-pass crypto protocol at the moment is the Chaminoki Protocol. The Messi-Omura crypto system is also proposed as an improvement of the Shamir protocol. Recently, new works aimed at the development of a three-pass cryptographic protocol have appeared. The exponentiation cipher is used to perform commutative encryption. At the same time, the exponentiation cipher is as safe as the problem of the discrete logarithm is. Accordingly, protocols based on the exponentiation cipher are not immune to attacks with the using hypothetical quantum computers. The paper presents a fundamentally new approach to construction of a three-pass cryptographic protocol. It is based on the representation of an information message as a permutation of numbers P with length M. A permutation on a set of M elements is a bijective reflection of some finite set X of cardinality M. The operation of cryptographic transformation for the proposed protocol is the operation of multiplying permutations, raising to the power of their disjoint cycles, as well as the operation of finding the conjugate permutation. The developed protocol can be used both for information transmission systems using factorial coding with data recovery by permutation, and for traditional systems that do not use factorial coding. In the latter case, the data transfer protocol must additionally include the procedure for the bijective reflection of the information block and permutation. The three-pass protocol includes the following procedures. Alice and Bob know the permutation alpha. Moreover, Alice and Bob know its decomposition into a product of disjoint cycles. The permutation alpha is stored in an open directory. Alice randomly generates her secret key in the form of a vector S. Next, Alice forms the key permutation sigma A. Also, Alice forms the permutation inverse to sigma A. Alice keeps the vector S and permutation sigma A and inverse to it in secret. Bob randomly generates his secret key in the form of a vector R. Bob then forms the key permutation sigma B and the inverse to it. In addition, Bob randomly generates the permutation he B. All disjoint cycles in the permutation sigma he B decomposition must be of different lengths. Bob keeps the vector R, permutation sigma B and inverse to it and he B in secret. Alice and Bob are responsible for disclosing their private keys. Alice wants to securely transmit the message M. Then the message M is mapped to permutation P. Alice calculates Y1 and sends it to Bob. Bob receives the message Y1, then he encrypts the received message Y1 by calculating Y2. Then Bob sends Y2 to Alice. Alice forms a permutation which is inverse to P. Then Alice removes her secret key sigma A from the received ciphertext Y2 by calculating Y3. Alice sends Y3 to Bob. Bob receives the message Y3 and removes his key sigma B by calculating Y4. Next, Bob introduces the resulting permutation Y4 as a product of disjoint cycles. The permutation P is formed from permutation Y4. Now, we show that if Alice and Bob do the above steps, they will implement the proposed 3-pass cryptographic protocol. The permutations sigma A and sigma B commute with each other. This implies that the permutations Y4 and HB are conjugate. Therefore, the permutations Y4 and HB have the same cycle structure. Their decompositions into a product of independent cycles for any L contain the same number of cycles of length L. The last expression defines the rules for the formation of the permutation P. Thus, performing these actions results in a secure exchange of information via unsecured channel without the need of a key sharing. So, the paper proposes a fundamentally new principle for the implementation of a 3-pass cryptographic protocol. Its basic feature is that it uses not just the operations of multiplying the information vector, permutation, key permutations, and their inverse, but uses permutation topology and nonlinear transformations based on the identical cyclic structure of conjugate permutations. Thank you for your attention.
Thank you, Professor Emil, very much for your presentation. If there is any questions, please, you are welcome. Okay, if there is no questions, we will come back to our previous presentation.
Thank you very much.
Thank you very much. We are coming back to our previous presentation from Professor Vladimir Lukin. Are you ready, Professor Vladimir, technically to present?
He's here, but it seems like his microphone doesn't work.
His microphone doesn't work. And what about Frank van Glee? Maybe he will present the...
He is not with us.
So okay. We have times, maybe Professor Lukin will recover his technical issues, and I think that we will come to our next presentation prepared by Professor Alexander Korchenko from the National Aviation University, IEEE senior member, and Professor Igor Teryakovsky from the National Technical University of Ukraine, named after Igor Sikorsky, also in Kiev. And the theme of the next presentation is determination of science of information and psychological influence in the tone on sound sequence. So, Professor Alexander, you are welcome. Do we have Professor Alexander Korchenko with us?
Yes, I've seen him, but give me a moment. Yes, he's here, but he doesn't respond.
Let's wait, maybe. The co-author is Professor Igor Teryakovsky. Are you with us today, Professor Igor?
Excuse me, Professor Alexander Kolchenko is ready?
He is here, but he doesn't respond.
Doesn't respond.
Okay.
There was some issues maybe.
Excuse me, participants. Maybe I'm my report.
Okay.
Yes, of course.
Okay. Yeah.
Yep.
On screen. Yeah.
Okay.
Maybe two words about the history. Our chapter report about organization concept of scientific and professional society IEEE Information Theory Society chapter. Excuse me. And now a few words about the history of our society creation. In February 2019, the initiative group of scientists from the Ukraine University and other universities started to work on the project of organization of professional society of information theory within the IEEE Ukraine section society. The idea of the project was to create IEEE Ukraine section society information Ukraine section society information theory chapter. As you know, IEEE is a world leader in information technology, standards development, and professional science grants, with headquarters in New Jersey, USA. On slide 4, you can see a focus area of the IEEE society. And very interesting areas: communication, networking, and broadcasting. 5 chapters: computer and processing, hardware, software, 6 direction and chapters, and another areas, professional areas on slide. The total number of the IEEE societies is 28, and any direction. IEEE Aerospace and Electronic Systems Society memberships and focus this direction organization: systems engineering, design, development, integration, and operation of the complex systems for space, air, ocean, and ground environments. IEEE Broadcast Technology Society's membership, IEEE Antennas and Programming Society memberships, and they're very interest for us. IEEE Communication Society membership, IEEE Computational Intelligence Society memberships, and IEEE Computer Society memberships, and Society Theory Society memberships, IEEE Information Theory Society membership, processing, transmission, storage, and the use of information to technical and applied aspects of coding, communication network. This focus is equivalent from conference ATIT’2020. And now on the slide, IEEE Ukraine section, Society Joint Chapter, technical chapter of the IEEE Ukraine section. Now 14 chapters, and Kharkov, Kiev, and other, and IEEE Ukraine section Information Theory Society chapter, and conference Advanced Trends in the Information Theory Advanced Trends in the Information Theories. Focus of IEEE Information Theory Society is on the present transmission, storage, and use information, and other position. Technical interests of the IT society focus on the theory and practice of information communication systems, network, data encoding, and other direct equivalent of focus of our conference. In the results of our work on the 23rd, 29th of September, received a letter from the IEEE USA authority, and all other regional chapters approved formation of our IEEE Ukraine section Information Theory Society chapters. And this chapter, the first society chapter for information theory in the 8 IEEE region. And you can see the room and our letter. Now the initiative group of scientists from IEEE Ukraine section Information Theory Society chapter and other universities developed the society activity plan on 2020, and its key event in 2020 is International Conference, 2nd International Conference on Information Theory. No, and track this. Thank you very much, and Professor Lukin, you ready? One minute, Professor Korchenko.
It seems like Professor Korchenko is with us but doesn't respond. And Professor Lukin has left the conference. I hope he will return. He had some technical issues.
Okay.
Excuse me, 1 minute.
So now we have a time when Professor Alexander is trying to reach Professor Korchenko for discussion if some of us has questions regarding the conference topic, so you are open for discussion.
Victoria, do you hear me now?
Yes, we hear you.
Okay.
Oh, Professor Lukin is with us. Are you ready, Professor?
Yes, I'm ready.
Okay, so let's start your presentation. Please, you are welcome.
I'm putting just on the screen.
Okay.
Do you hear me? Do you hear at the screen my presentation?
Yes, we hear you well, and we see your presentation. You can start.
Okay. Dear colleagues, sorry for some technical problems, and I'm glad to welcome you here at this conference. And let me present our report that has been prepared by me and my PhD student from China. It is called An Approach to Better Portable Graphics Compression with Providing a Desired Quality. The outline of my presentation is the following. It includes introduction, motivation, research purposes, and the main body of this presentation is the two-step method of BPG encoding, when we analyze the results and give some conclusions. So, nowadays there are numerous applications where image compression is needed, and it is necessary to compress images with providing quite high compression ratio, but at the same time it is also needed to provide an appropriate quality of these images, especially visual quality. So the basic advantage of processing is that compressed images occupy less space, and if we transfer images via communication lines.
Excuse me, Professor Lukin, full
yes.
screen, please.
Yes, okay. Okay, and there are lossless and lossy compression, and it is known that lossy compression allows us to provide a rather high compression ratio, but at the same time we need to provide an appropriate image visual quality. One recently proposed method of image compression is called Better Portable Graphics, and the abbreviation is BPG, and it has been proposed in 2014 in the paper that you can see at the screen. And the main advantages of this method are the following. First of all, it has open source that can be accessed. Second, it provides a higher compression ratio than JPEG and many other coders with similar quality. It has wide support for different chroma formats mentioned at this slide. It provides JavaScript decoder, which is light for browsers and other portable applications. And it supports lossless and lossy compression. Here is a table that shows advantages of this coder. If we have PSNR peak signal to noise ratio desired about 35 dB, then BPG provides only slightly benefits compared to SPICT, and if the desired PSNR is 30 dB, then you can see that BPG provides several times better compression than SPICT. At the same time, in some applications, one might need a desired visual quality, and this visual quality has to be provided with high accuracy. BPG coder is controlled by parameter called Q, and we will show later that this parameter Q, in some sense, certainly controls quality, but quality of compressed images can differ a lot. So we have proposed a two-step procedure to improve it. Two-step method is a novel approach. It has been used for many coders, including AGU, ADCT, SPICT, and it has shown itself well enough. And it compresses image, then decompresses it, then calculates the metric, and then determines what should be parameter that controls compression to provide a desired quality. And this method is based on the so-called averaged curves. And you can see here PSNR dependence on Q, and you will see that in general that the tendencies are the same, but for each particular image, we have particular rate distortion curve. And for example, for Q equal to 30, we have difference in PSNR values of about 6 dB. And the same holds for other metrics like PSNR HVS metric, PSNR HVSM metric that has been proposed by us, and that is characterized by good adequateness for image processing applications. And it takes into account two properties of human vision system, namely masking effect and different sensitivity to distortions. We have used a set of images, and it includes both textural images like baboon, or for instance texture 3, texture 4, and simple structure images like Lena.
Алло?
Using these
А я
images,
смотрю, по
we
расписанию
have
профессора
good
Эмиль из
average
Черкас.
curve,
Он же, кажется, не выступал.
and also we have determined derivative for each point of this average curve. And
я
this
понял.
average curve is needed for us
Тогда Корченко еще
to
ждем
carry
или
out
уже
this
закрывать?
first step of compression. And you can see here that for the same Q, there are quite different values of parameter. So the two-step method of BPG encoder includes calculation of the so-called Q initial used at the first step, then compression with this Q initial decompression, and calculation of the metric value, and then after this we can calculate the Q desired according to this quite simple linear approximation formulas, where M in denominator determines derivative, and due to this it is possible to carry out compression final. You see here the simulation results for two desired values of PSNR and three desired values of PSNR HVS equal to 40, 35, and 30 dB, and variance after the first step and variance after the second step. And as one can see, it is possible to decrease variance due to the second step by about several times, or even one order in some cases. And this means that we can sufficiently improve the accuracy of providing a desired value of the considered metric. Max values are given in the rightmost column. Here are more detailed information for one particular case, and you can see that the provided values of PSNR HVSM are quite close to the desired value 35 dB, except of several images for which the accuracy has been approved, but still there is some error in providing a desired value. And in the last line, you see that we have improved variance by 3 times, or even more than 3 times. Okay, concerning conclusions, a two-step experiment for grayscale images using BPG encoder has been done, and it shows that it is possible to improve accuracy of providing a desired PSNR and PSNR HVSM due to two-step procedure, and accuracy has been improved by several times. And it is interesting that there are even such images that a single step can meet the accuracy requirements. And thank you for your attention.
Thank you, Professor Vladimir, for your report. It was very interesting to listen it. If there is any questions, please ask. No questions here.
Okay, thank you very much. And now let me close the plenary session. And after the technical break, we will continue working on track 1 after plenary sessions. Okay.
So thank you everybody for your participation and for your time. I hope it was interesting for you, and see you all after our technical break.
Thank you, dear participants. The first chapter will start in 1 hour at 1 o'clock. The leader will be Professor Baranik. I will also help him and as technical support. Please look for the link in your programs, or you can ask your chapter leader. Thank you for your attention and for being with us here today.
Thank you.
Thank you for your time. Talk to you soon.
Talk to you soon.
Thank you.